Hi, my name is Gavin Ruane, and I'm a student in CPE 233, Section 7, and this is my Lab 9 Project D submission video. For this lab, students were tasked with pretty much refactoring what they did in Lab 8, which was to have a program that will either increment or decrement the count displayed on the 7-segment display when a button is pressed. And last week we implemented this using the interrupt button. So when the interrupt button was pressed, we would increment the display. This week it's going to look very similar to you, the viewer, but this week we're actually using the interrupts in our system with a timer counter module, which is multiplexing the display for us. And the button is just going to be pulled, I guess you could say, because it's not the button value will not be grabbed from the interrupt port. So this week it's going to look very similar to what we did last week, but I wrote down some conditions that are going to test and show and make sure that this still works and that it works in this new context where we've swapped out kind of how we're handling things. So one more thing on that note too is that I forgot to mention earlier is we're debouncing in firmware this time. So last week we used a debounce module as well as a one-shot module, and that was connected to the interrupt port in our auto wrapper, which would then send, which when we click the interrupt button, the signal will be sent through those modules. This week, we're doing that in firmware, and our interrupt port is going to be used for the actual multiplexing of the display. So, okay, let's get started. Let's actually do some tests. Let's go through our conditions, and you'll see, it's going to be very similar to last week. Okay, for the first one, button initiates an increment or decrement. So I'm going to flip this switch up real quick, and I'm going to hit the button, and yeah, it initiates an increment. And then I'm going to flip it down, I'm going to click it, and it's going to initiate a decrement. So that part works, our button works. And then I already showed these two too, but I'm going to do it again. It's going to increment when the switch is up, so I'm going to flip this rightmost switch up, and yeah, we're going to increment. We're going to keep going up. So that test or condition is passed. And then when I flip this rightmost switch down and I hit the button, we're going to go down. Okay, and then the next test is that the button is debounced on the rising and falling edges. And what this means also is that holding the button does not change the count. So if I hold the button, I don't want this to keep going 1, 2, 3, 4, 5. I just want it to stay at 1. This also means that when I hit the button, I don't want it to think that there are maybe 2 button presses. And again, this is when you hit a button and there's some noise in there, and then our system, which is very fast, is interpreting that noise as additional button presses. We don't want that to happen. I just want it to do 1 button press. So I'm going to go back to the beginning. I'm going to start over at 0, and I'm going to demonstrate this for you. Okay, I'm going to flip the switch up so we can increment. First, I'll show you that when I hold the button, it's not going to keep going. So I'm going to hold the button, and I'm still pressing down, but we're not going up 2, 3, 4. We're staying here. You have to press it again to actually go up. So we passed that condition. The debounce is, I guess, harder to demonstrate, but at the same time, it's also easy because you'll notice that when I click the button, we're not going to accidentally increment by 2 or something. Like if I click it, it's not going to go 7, 8 really quickly. It's only going to go to 7 and it's going to stay there. That's because I've implemented a pretty decent debouncing period in the firmware that I designed for this program. So debouncing is enabled on rising and falling edges. And then finally, the count it needs to be in the range from 0 to 20. We're not going to go above or below. So we're at 7 right now, and I'll just go all the way up so you can see this. Okay, so we're at 20. I'm going to keep clicking. You can probably hear it. We're not going up anymore. We're stuck there. And then I'm going to flip the switch down to decrement. I'm going to click it again. Now we're at 0. I keep clicking. Nothing's happening, which is exactly what we want. We don't want to keep going below 0. That wouldn't make any sense. And finally, lead 0 blanking is used. This is pretty much what we did last week too, but it's just saying, okay, like right now, there's nothing on this display that I'm pointing at right now because we're just showing 1-digit numbers. But when I go into 2-digit numbers, we are going to display something on that display. And, this just makes sense because it wouldn't be the worst thing in the world if we had like back down here, 07, but it's not readable. And also it does save a little bit of power, so we can always take that as a win. Okay, so we passed that condition and we passed all the conditions. And that's pretty much it for this project. So again, it was very similar to last week. It was just kind of a refactoring, but it did implement a new module, which was interesting, and we got to check that out and play with that. So thanks for watching, and I guess this is the last submission. So thanks for watching my submissions this quarter.